Each octet in the IP address has a value ranging from 0 to 255. Let's see how we get that. So it's an octet, there's 8 bits there. Let's count them out. So 1, 2, 3, 4, 5, 6, 7, 8 bits. And it's binary, so the rightmost digit or the rightmost bit is going to be a 1, either a 0 or a 1, and then we're going to double each time we add a bit to the left. So it goes 1, 2, 4, 8, 16, 32, 64, and 128. It's binary, so we multiply by 2, we double each time we go up. And the values are going to range from 0 to 255 for each octet in our IP address. If we put a 0 in on all of those bits, obviously all zeros adds up to 0. If we put a 1 in on each of the bits, if you add these up, 128 plus 64 equals 192, 192 plus 32 equals 224, 224 plus 16 equals 240, 240 plus 8 is 248, 248 plus 4 is 252, 252 plus 2 is 254, and 254 plus 1 is 255. Now, if you're wondering how I was able to add those up so quickly and it didn't even look like I was thinking about it, yeah, that's right. When you get more experienced with networking, this is going to be second nature to you. IP addressing is really core to everything that you're going to be doing. So you're going to know IP addressing and its format like the back of your hand, just like I just showed you there. Okay, so that's how we can get the values from 0 to 255. On each of those octets, the bit pattern in here on each of those different bits can be any combination that you want of 1s and O's. It goes from 0 at the lowest value up to 255 at the highest value. The example IP address I gave you earlier was 192.168.10.15. That's in dotted decimal notation. Let's convert that to binary. So the way that you do this is get a piece of paper and a pencil and write out what you see here on the slide. So starting from right and go to left, write out 1, 2, 4, 8, 16, 32, 64, and 128. And then to figure out what your IP address is in binary, start off with the first octet is 192. So we'll do that. And the first thing to do is you start going from left to right. So when you write it out, it's easiest to write it from right to left. But when you're figuring things out, we go from left to right. So the first thing to ask is, can 128 go into 192? Or is 128 equal to or less than 192? And yes, it is. So if that's the case, we put a 1 under the 128. Then what we do is we see what we've got left. Well, 192 minus 128 is 64, so we've got 64 left. We then go to the next column and see, does 64 go into 64? Yes, it does, so we put another 1 in there. We then take the 64 away and we're left with 0. Then does 32 go into 0? Obviously not, so it doesn't go, so we put a 0 there, and it's pretty obvious we've got 0 left, so we're going to have 0 on all of the rest of the columns. So 192, if we were going to write that in binary, it is 11000000. And then to do a final check, to check that we got this right, add these digits together. So add 128 plus 64. When we add them together, it comes up to 192, which is the value we wanted. So we know that we got that right. When you're working this out, if you ever get anything that does not end with a 0 value, you know you've made a mistake. So go back and try it again. Okay, so that was our first octet. Let's do this same process again for the second octet of 168. So does 128 go into 168? Yes, it does. So we'll put a 1 in there. And then the difference between 168 and 128 is 40. We've got 40 left. Does 64 go into 40? No, it doesn't. So we put a 0 in that column. Then does 32 go into 40? Yes, it does. So we put a 1 in there, and then 40 minus 32 gives us 8 left. 16 does not go into 8, so we'll put a 0 in there. 8 does go into 8, so we put a 1 in, and 8 minus 8 gives us 0 left, so we know we can just fill in the rest of the columns with a 0. So 168 in binary is 101010000. And our final check, add the numbers together. 128 plus 32 plus 8 does equal 168. So we got that one right as well. So the first half of our IP address in dotted decimal is 192.168. In binary, it's 110000.101010000. So hopefully you followed along with that okay. What I want you to do now is to stop the video and work out the last 2 octets yourself. So convert 10.15 into binary. And when you've done this, I want you to give me the entire IP address in binary notation. So what your output will be is 11000000 dot 10101.000 dot, and then the next octet in binary, and then another dot, and then the final octet in binary. So go ahead, stop the video now, and we'll check your answer in a second. Okay, so hopefully this is the answer that you got. 192.168.10.15. So the first octet was 11000000. 128 plus 64 equals 192. The next octet of 168 was 10101.000. 128 plus 32 plus 8 equals 168. The next octet, you should have got 00001010. 8 plus 2 equals 10. And then the last octet of 15, you should have got 00001111. 8 plus 4 plus 2 plus 1 equals 15. And if you look at the top of the slide here, that should have been your final output. That is the complete IP address in binary. Hopefully you found that really simple. With just a tiny bit of practice, you'll be able to do this without hardly even really thinking about it. Okay, so that's how we figure out the IP address. To set the boundary between our logical networks, our subnets, the IP address is going to be combined with a subnet mask. And you'll learn about the subnet mask in the next lecture.